When a person feels an intense pull toward sugar, the common explanation is moral weakness, a failure of control, discipline, or commitment. Yet the human body does not operate on moral logic. It operates on chemistry, survival, and energy balance. Sugar cravings emerge not from character flaws but from instability in blood glucose, a condition the brain perceives as an immediate threat. The brain's primary responsibility is to keep the body alive, and its preferred fuel is glucose. When blood sugar rises sharply and then falls just as quickly, the brain interprets that drop as danger. It does not pause to ask whether the drop was caused by a pastry or a stressful morning. It simply reacts. Inside the bloodstream, glucose levels are tightly regulated under healthy conditions. When refined sugar is consumed, glucose floods the blood rapidly, prompting the pancreas to release insulin. Insulin's role is to move glucose into cells for energy or storage. But repeated spikes force insulin to work harder and more frequently. Over time, cells respond less efficiently, and glucose lingers in the blood while cells remain underfed. This paradox, plenty of sugar in circulation but not enough inside the cells, creates an internal energy crisis. The brain senses this mismatch and demands fast fuel, often in the form it recognizes most easily, sugar. Cravings, then, are not random desires. They are emergency signals. The brain does not understand nutrition labels or dietary intentions. It understands energy availability. When glucose delivery becomes unreliable, the brain amplifies hunger signals and narrows food preferences to what it believes will restore balance quickly. This is why sugar cravings feel urgent and emotionally charged. They are not gentle suggestions, they are survival alarms. Understanding this changes the emotional relationship people have with cravings. Instead of shame, there can be curiosity. Instead of resistance, there can be inquiry. What caused the blood sugar swing? Was it a meal lacking protein or fat? Was it prolonged stress elevating cortisol, which raises blood sugar and then crashes it? Was it poor sleep, which disrupts insulin sensitivity the following day? The craving itself becomes a clue, not a failure. When blood sugar stabilizes, cravings naturally soften. This stabilization does not require extreme restriction but rather consistency. Meals that include protein slow digestion and provide amino acids for neurotransmitters. Healthy fats delay gastric emptying, smoothing glucose release into the bloodstream. Minerals like magnesium and potassium support insulin signaling at the cellular level. With these supports in place, glucose enters cells more efficiently, and the brain senses safety rather than scarcity. The most important realization is that discipline is not the primary solution to sugar cravings. Biology is. When the body is supported, cravings fade without force. When it is ignored, cravings intensify regardless of motivation. This reframing removes self-blame and replaces it with responsibility, not responsibility to resist, but responsibility to nourish. The body is not asking for sugar, it is asking for stability. When that request is honored, the craving loses its urgency, and eating becomes calmer, more deliberate, and more human. To understand why sugar cravings can diminish dramatically within 48 hours, one must look closely at two powerful hormones, insulin and cortisol. Insulin governs how glucose enters cells. Cortisol governs how the body responds to stress. Together, they shape appetite, energy, and emotional eating patterns more strongly than conscious intention ever could. Insulin is often discussed only in the context of diabetes, but its influence extends far beyond disease. Every time food is consumed, insulin responds. In a balanced system, insulin rises gently, delivers glucose efficiently, and then returns to baseline. Problems arise when insulin is triggered repeatedly by refined carbohydrates and sugars. Chronic elevation leads to resistance, meaning cells stop responding properly. When this happens, glucose remains in the blood while cells remain hungry. The brain, sensing cellular starvation, increases appetite signals, particularly for fast-acting carbohydrates. Cortisol complicates this process. Known as the stress hormone, cortisol's role is to mobilize energy in times of threat. It raises blood sugar so muscles and the brain can act quickly. In modern life, Stress is rarely physical and rarely brief. Emotional pressure, financial worry, sleep deprivation, and constant stimulation keep cortisol elevated for long periods. Elevated cortisol raises blood sugar, which triggers insulin, which then drives blood sugar down, often too far. The result is a crash that feels like exhaustion, irritability, and intense craving. When refined sugar is removed and replaced with stabilizing nutrients, insulin secretion becomes calmer. Protein and fat do not provoke sharp insulin spikes, allowing levels to normalize. As blood sugar steadies, cortisol no longer needs to intervene to correct perceived emergencies. Within the first 24 to 48 hours, many people report a surprising sense of calm. This is not psychological coincidence, it is hormonal relief. Reducing cortisol is not only about food. It is about rhythm. Eating regularly prevents hypoglycemia, which otherwise triggers cortisol release. Adequate sleep restores insulin sensitivity. Gentle movement improves glucose uptake by muscles without demanding insulin. Even breathing patterns influence cortisol output through the nervous system. When these factors align, the hormonal environment shifts from urgency to stability. The speed of change often surprises people. They expect cravings to fade slowly, but hormones respond quickly when conditions change. The body is adaptive. When it senses consistent fuel and reduced stress, it downregulates emergency signals. Hunger becomes informative rather than compulsive. Desire becomes choice rather than command. What is most transformative is the emotional impact. When cortisol drops, food loses its role as emotional anesthesia. Eating becomes nourishment rather than coping. The mind clears because glucose supply to the brain is steady. This is why addressing insulin and cortisol together is so powerful. It treats cravings at their root, not their surface. Within 48 hours, the body can remember what balance feels like, and once remembered, it often seeks to maintain it naturally. The liver is often overlooked in discussions about cravings, yet it plays a central role in energy regulation. Acting as a metabolic hub, the liver stores glucose as glycogen and releases it between meals to keep blood sugar stable. When sugar intake is excessive, this system becomes overwhelmed. The liver fills its glycogen stores quickly and converts excess glucose into fat. Over time, its ability to regulate blood sugar smoothly diminishes. When refined sugar is constantly present, the liver is forced into a reactive state. Instead of releasing glucose steadily, it responds to hormonal chaos created by insulin spikes and crashes. This instability disrupts communication between the liver and the brain. The brain relies on consistent glucose delivery. When that delivery becomes erratic, the brain interprets the situation as fuel insecurity. Removing sugar gives the liver space to recover its regulatory function. Within the first day, insulin levels drop, allowing the liver to begin releasing stored glycogen more gradually. By the second day, the body may begin shifting toward fat metabolism for supplemental energy. This transition reduces dependence on frequent glucose spikes and stabilizes blood sugar between meals. As energy delivery becomes smoother, the brain's alarm system quiets. Cravings diminish not because the brain has been denied sugar, but because it no longer fears running out of fuel. Cognitive clarity often improves during this period. People describe feeling more present, less reactive, and more emotionally even. These changes reflect restored metabolic communication rather than psychological effort. The liver also plays a role in detoxification and hormone metabolism. Excess sugar burdens these processes, diverting resources away from balance. When sugar is removed, the liver can better process cortisol, estrogen, and other hormones that influence appetite and mood. This hormonal recalibration further reduces craving intensity. What emerges is a sense of internal coherence. Hunger aligns with actual energy needs. Satiety signals become reliable. The brain and liver resume their quiet conversation, one based on trust rather than emergency. This is why cravings often diminish rapidly when sugar is removed thoughtfully rather than replaced with refined substitutes. The goal is not deprivation, but metabolic dialogue. In this restored state, the body becomes an ally again. It communicates clearly, and its signals are easier to interpret. The craving that once felt overwhelming now feels distant, even irrelevant. Not because sugar was demonized, but because the system no longer depends on it for stability. Inside the digestive tract lives a vast ecosystem of microorganisms that influence appetite, mood, and metabolism. These microbes are not passive passengers. They actively interact with the nervous system through chemical signaling. Certain bacteria thrive on sugar and refined carbohydrates. When they are abundant, they release metabolites that increase desire for the foods that sustain them. This relationship explains why sugar cravings can feel almost external, as if something is pulling the appetite in a specific direction. In a sense, something is. The gut microbiome communicates with the brain via the vagus nerve and chemical messengers. When sugar-loving bacteria dominate, they amplify craving signals. When their food supply is reduced, their influence weakens. Within 24 to 48 hours of removing sugar, the microbial environment begins to shift. Bacteria that rely on fiber, fats, and proteins gain advantage. These organisms produce metabolites that support satiety, reduce inflammation, and improve insulin sensitivity. As their influence grows, craving signals change. Hunger becomes slower, more physical, less urgent. This microbial shift is not instantaneous, but it begins quickly. The gut is highly responsive to dietary change. Even a single day of altered intake can change microbial activity. This is why cravings often ease sooner than expected. The chemical messaging to the brain is changing at its source. Importantly, this process is not about eliminating pleasure. Many gut-supportive foods enhance taste sensitivity over time. As sugar influence fades, natural flavors become more vivid. Sweetness is perceived more intensely even in whole foods. This sensory recalibration further reduces the desire for refined sugar. Supporting this transition with fiber, fermented foods, and adequate hydration accelerates the process. These inputs nourish beneficial microbes and reduce inflammatory signaling that can drive emotional eating. The gut becomes calmer, and so does the mind. Recognizing the role of gut bacteria removes yet another layer of self-judgment. Cravings are not purely psychological, they are ecological. Change the environment, and behavior follows. Within 48 hours, many people feel a shift that seems disproportionate to the effort made. That shift reflects a biological realignment happening below conscious awareness. At the deepest level, cravings represent unmet needs at the cellular level. Cells require energy, amino acids, fats, vitamins, and minerals to function. When these needs are met, cells send signals of sufficiency. When they are not, the brain interprets the deficiency as hunger, often nonspecific and urgent. Sugar provides rapid calories but little cellular nourishment. It raises blood glucose but does not supply the building blocks required for repair, signaling, or resilience. When a diet relies heavily on sugar, cells receive energy without nutrition. Over time, this creates a paradox of excess and deficiency simultaneously. Proper nourishment resolves this paradox. Protein provides amino acids for neurotransmitters that regulate appetite and mood. Fats supply stable energy and support cell membranes. Minerals enable enzymes to function efficiently. When these needs are met, cells communicate satisfaction. Appetite becomes quieter, more precise, and less emotional. This is why cravings often disappear not when calories increase, but when nutrition improves. The body is not seeking volume, it is seeking quality. When that quality is delivered, urgency fades. Eating becomes intuitive rather than compulsive. Within 48 hours of nourishing meals, many people experience a profound shift in relationship with food. They feel fed, not just full. Their thoughts about food occupy less mental space. This mental freedom is a biological outcome, not a psychological trick. The most powerful aspect of this process is trust. When the body learns that nourishment is consistent, it stops demanding quick fixes. Cravings lose their authority because the underlying need has been met. This is not control imposed from above, but cooperation built from within. In this state, health feels less like discipline and more like alignment. The body and mind move together rather than in conflict. Sugar cravings, once loud and persistent, become quiet reminders of a system that has learned how to care for itself again.